here to introduce Arphic's Chinese font developing system. Arphic is a Taiwanese font company. Next year is our 30th anniversary of establishment. That means we have 30 years in developing Chinese fonts. In the very beginning, when a digital font is just developed, the font tool was very expensive and not beneficial for designing Chinese font. That's why we established as a tech company to develop our own unique stroke-based technology and the font developing system. In the first 20 years, our technology led our font design and applications, but since 2010, we embarked on a transformation to become a design-oriented Chinese company to develop typefaces. Optimizing the process of creating fonts helps designers to increase the efficiency of drawing and produce high quality of fonts. I'm going to show you how we do it. I would like to first introduce the process of Arphic's type design. There are 5 steps of Chinese type design. Step 1, designers draw representative characters with their creativity according to how the type will be used. Step 2, define the structure of the entire set of font based on the representative characters, such as letter size, weight policy, and analyze and design shared strokes. Step 3, design all characters according to what the character set needs. Step 4, quality inspection is a very important work. We usually need several designers to create one set of Chinese font. The responsibility of the chief designer is to check the quality of each designer's output. This step is always carried out with mass production of characters back and forth for many times. Step 5, productization, transforming the Chinese Latin and the symbol characters into OpenType font files and testing them on Windows and Mac OS. We choose 15 Chinese characters as the initial representative of design concept. Some of them are with fewer strokes, some are more strokes, some are with more, some are in between. They also include the most frequently used characters and several component combinations. Here is the example of AR Jingxi He. The chief designer describes the design features of strokes, such as counters, letter sizes, and structural specification to be the standard for design this typeface. After 15 sample characters has been approved, we started to design 66 representative characters. The strokes in the sample already represent 1/3 of strokes in this font. For example, Jingxi He consists of 770 strokes in total, and we need 250 strokes of them to design these sample characters. Those samples also represent the typical appearance of Chinese characters, like rectangle, square, circle, and triangle. Since there are tens of thousands of characters in Chinese fonts, we usually need 2 to 5 designers to work together. Each designer can create 50 to 100 new characters each day. Then, the chief designer will inspect the quality of these outputs. mark the areas that need to be modified, and give feedback to the collaborative designers to ensure the coordination of the entire font. We can see one of the examples on this page. Even though the designer put a lot of effort into those characters, the chief designer still proposed so many change marks. I guess the designer would probably be very upset. But this shows how difficult it is to design a high-quality font. Then finished a set of traditional Chinese font. Here is the most complex Chinese characters. The character at the upper left corner has 48 strokes. This page shows the entire set of Big Five with total 13,060 Chinese characters. This is the initial representative characters of the simplified Chinese. The typeface is called Moji. Chinese name is Bai Yu. It means white jet. It just released in this August and received a positive market response. These are the 66 representative characters selected from simplified Chinese. This is the finished work. The characters on the top contain the fewest stroke, 1. There are 6,763 Chinese characters in this GB2312 character set. If we want to upgrade to GB18030, which is the GB large character set, we need to design 27,533 Chinese characters. It is a tremendous amount of work. Next, I will introduce Arphic's stroke-based font technology and its font maker. We have been using stroke-based technology for 29 years. There are two important features of it. First, programmed strokes using the parameter of structure points and the stem width to adjust the strokes. Second, using two extremes of weight axis to interpret new instances, like the concept of variable fonts. We use the parameter mentioned above to interpret instead of Bezier points. I will play a video to show it. And the process at the top half is the design process that I mentioned before. Okay, the top half of the design process that I mentioned before. The bottom half
shows
is
the characters of Shu Yuan Song from GB2312 simplified Chinese character set. The stem width of horizontal strokes of these characters are 32. Font weight is heavy. We choose the character Xia to demonstrate the process we create fonts. Arphic has its own font creating tool and engine, and a unique font creating process. First, we could use a font master or use the existing data to create new fonts. According to the features of different Chinese typefaces, we create Chinese fonts with strokes. Let's start from the strokes. After classifying strokes, we digitalize the modules using Arphic's graphic design language maker. You could call it GDL Maker. to set up movable control points and widths to draw a stroke. This stroke is from the character dong, which the designer has done in the very beginning for being a shared stroke module. This is the stroke module after being digitalized in a font creating system. We use the stroke module to create new fonts. Shuyuan Song has 785 stroke modules, and we could use the stroke modules to create almost 30,000 Chinese characters. Next, we use the character xia to demonstrate how we create fonts. You can see a sample of character xia in the up left corner for designers to follow how it should be composed. So the designers could choose a proper stroke from the modules to draw and compose strokes. Then, we will create a different character xia. We could use the character xia, which we have just done in the previous step, to adjust the structure and change strokes. Using the radical an, which we have done and saved in the up left corner to compose and adjust space, gravity, and structure. After the character xia is done, we could lay out with other characters to check the quality, setting the sizes in the menu to check the balance of xia and xia in both radical and horizontal sentences. Based on the font of heavyweight, horizontal stroke stem width of 32, we could set up parameters to change the stem width of horizontal strokes in the font creating tool to create fonts with different stem width of horizontal strokes. The outline of fonts. Parameters of horizontal stroke stem width of these four fonts are 16, 32, 46, and 62. The outlines which show the different stem widths of horizontal strokes. Stem widths of horizontal strokes of the four fonts changes. You could see it in the screen below. It shows stem widths of horizontal strokes of 16, 32, 46, and 64. 4 TrueType fonts with different horizontal stroke stem widths. We have done the font of heavyweight. We can use the heavyweight to create medium weight. Based on heavyweight, stem width of horizontal strokes 32, to set up the parameters of vertical and diagonal strokes. Then we could preview the fonts of medium weight with horizontal strokes stem width 32. Below shows fonts of medium weight. Designers could also see the unsmooth curves and unbalanced structures caused from the process of transforming heavy to medium. When transforming fonts from heavyweight to medium, we will adjust the shape of strokes and the structure of characters. This is the adjust of outline curves of medium weight stroke module. After fixing the stroke module, we could go back to the font creating tool to adjust structures and gravities, using heavyweight characters as samples to adjust medium weight characters. We have done the heavy and medium weight. Then we could interpolate weights of demi-bold, bold, extra bold in between. This is the demonstration of 2 dimensions of Arphic variable font Shuyuan Song.
Okay, so this is demo our font tool, how to make a typeface and then expand it to other font family. It's very easy to read. And then I introduce how to create the Chinese variable font, the process and the tools. Based on the technology of Arphic GDL font, we have two methods to develop variable fonts. First, developing the most commonly used font, then expanding the two extremes of its axis. The two, developing two extremes of each axis, like a so and so. The emoji is the example that is applied in the first development model. Develop the most commonly used weight, regular, and then to expand that to light and bold fonts. When we start to design emoji, we thought the regular font would be the more suitable for the targeted applications. So we developed the regular font only. Later on, we found that the thinner and bolder fonts also have a great effect. Therefore, we decided to develop other two weight by using GDL stroke, of which the advantage is easily to change the stem width. The black one and the red characters above were generated by Arphic FontMaker automatically. Its quality is generally good, even though some details may need to be revised. In order to maintain the characteristics of the emoji, the designer reset the parameter values of the stroke width for the light typefaces, or the vertical stroke width multiplied by 50%, or the dot width multiplied by 83%, and keep the horizontal strokes unchanged. The production of the bold typeface used in the same way, but with different values. And the Jingxie applied the second method, developing two extremes of each axis. It has two axes, weight and width. The first designer designed the font pointed by the arrow. This variable font is on the Arphic's iPhone Cloud platform. Feel free to try it if you are interested in. After OpenType 1.8 was launched in ETABI 2016, we have changed our font tools and the process. First, besides the original weight, we add the second axis width to the major typefaces. Second, the way we created the variable font master is almost the same as before, but we need to make sure all control points of the corresponding strokes is compatible. Take the development of two axes of Jingxie as an example. To complete a simplified Chinese font which contains 28,000 Chinese characters needs 770 strokes, and each of four masters of two axes has their own stroke library. If we make sure the compatibility of all the corresponding strokes, then we can generate a variable font easily. Take this stroke in the red circle, for example. This stroke used by 30 characters on each typeface. The shapes could be changed by setting the stem width and the structure points. For creating the variable fonts, we have to verify what this stroke in the font master is compatible. The FontMaker shows failure of interpolation because the curve which are marked in the red circle need to be fixed. After we modify the depth part by using two quadratic Bezier curves, then two strokes are comparable. After we verify all 770 strokes are comparable, we can export as a Chinese variable font with two axes. Sounds easy, right? Nowadays, the topic of artificial intelligence is prevailing. We want to introduce AI technology into Arphic's font making process to help designers, and we already saw the preliminary result. We use decision tree-based algorithm and developed an intelligent program to help designers create fonts. We call it automation. So what can this program do? Let's look at some examples. First, the automation is emulate designers to copy a font master. This example shows that the automation uses Jingxi font database to imitate the bitmap of the character C. The program chooses some GDL strokes and try various parameter values to fit the font master. For getting the best fit values, it could try millions of times for each character. So it will take several days of computing power to create Chinese font. Fortunately, the computer will not tired, and the computing cost is also not expensive. Of course, automation can also transform the existing GDL styles. It will do the stroke pairing first, and then copy parameter values. This advantage is easy to create more new styles. For example, the above is the UD Jingxi, which has Dutch counter and letter size. Automation uses the strokes and the weights of the upper character and uses the lower character structure to generate a new style Jingxi with smaller counter and a smaller letter size. The other example, we use the strokes and the structures of the upper characters to match the weight of the lower character to generate a new weight of bold. This is a way to expand the font family automatically. The new research is to apply deep learning models to learn how to transfer the style in the source image to the target image. We use the bold and the hair. We use bold and the hair image as input to train the model, and this deep learning model can remember the features of the image eventually. This model becomes an expert of this style and learn how to transform image of Jingxi from bold to hair. The generated image could be input of the automation for converting to GDL font. Lastly, I introduced the new method still under study, which is to use deep learning algorithm to design new styles with GDL stroke directly. Here are the steps of the method. First, the learning data presented on the previous page are used as known data set. For example, it knows how to draw the character ye. the Chinese character at the bottom. For example, it knows how to draw the character here. Second, convert the GDO stroke data into a stroke space that can be used for deep learning. During the training process, continue to use GDO stroke data to test the combination of strokes in the best fit to the target. Step 4, after that, we will convert the corresponding image to the GDO parameters. Finally, the ye at the lower character, GDO character in the lower right corner is generated. Using the same method to all the characters to generate a complete set of GDO fonts. This research still be a would be a tough challenge. Fortunately, now we are making some progress. We hope having good results to integrate them into font developing process to help designers in the near future. Thank you for listening.
Thank you.